Hi, this is my solution to the Revenge of the Pancakes Google Code Jam. It seems qualification round in 2016. Question B. Took me about 1 hour or so to complete. I definitely skimmed over it the first time, thinking I understood how to do it. Then I started to make a video on the solution, which didn't go well, or as planned. I found out that my solution wasn't correct, and then I reread it, went over it again, found out that my audio wasn't working. So now this is the last time I will be recording it, hopefully. And so here's my solution. So the problem. The Infinite House of Pancakes has just introduced a new kind of pancake. It has a happy face made of chocolate chips on one side and nothing on the other side, blank side. You're a head waiter on duty. Kitchen has just given you a stack of pancakes to serve to a customer. Like any good pancake server, you have X-ray pancake vision, and you can see whether each pancake stack has the happy side or blank side up. You think the customer will be happiest if every pancake is happy side up when you serve them. You know the following maneuver. Carefully lift up some number of pancakes, possibly all of them, from the top of the stack, flip the entire group over, and then put the group back down on the top of any of the pancakes that you did not flip. When flipping a group of pancakes, you flip the entire group in one motion. You do not individually flip each pancake. So it has to be a group of them. Normally, if we number the pancakes 1, 2, and from the top, you choose the top I pancakes, flip them, then after the stack, it is I didn't understand this at first. This whole thing of flipping, I assumed if you go here that if you flipped, let's say if you flip this, so two things I made mistakes on. If you flip it, I soon to realize, which makes sense, that this becomes the last pancake for the stack that you flip. So if you flip this, it would be minus, plus, plus to start it, and then a minus, because this, when you're flipping it, yeah. And the second thing I didn't realize was you can only flip from the first pancake. I will show you here as we go further. Let's see, let's example. Let's denote the happy side plus, blank side minus. Suppose that's the stack starting from the top is minus, 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 plus, minus. One valid way executing would be to pick up the first three. This is when I realized it. One valid way, and then the fourth pancake, the new state would be minus, plus, plus. So when I thought of it first, I was like, wouldn't it be plus, plus, minus? It said minus, plus, plus. Then I realized, oh yeah, so it had to be minus, plus, plus, minus. Other valid ways would be to pick up and flip the top one, the top two, or all four. It would not be valid to choose and flip the middle two or the bottom one. For example, you can only take the same number off the top. I didn't understand this until I went to one of the examples, example 5. I thought, shouldn't this be 2 moves? But it was actually, what was it, 3 moves? Because I thought, oh, this becomes plus plus. This is a plus. Turn this to a plus, that's 3 moves. But you have to start from the first every time, so this becomes plus plus plus. You have to then reverse these so they all become minuses. Then at this point, they all become pluses. Well, at least that was my solution. I think some other people might have done a different solution, and this is different from mine. I'll go over it later. So you'll not serve the customer until pancake side is happy or happy side's up. But you don't want the pancakes to get cold. So you have to act fast. What is the smallest number of times you'll execute the maneuver to get all the pancakes happy side up? If you make optimal choices, the first line of the input gives the number of test cases, t, blah blah. So it's a string. When I first did, I did it with. I didn't realize that there was an input folder, or sorry, input file that was going to be used. So solve be small, somewhat. So I just tried to make classes and then assign type values and then change those properties of each element in the list, if you understand what I'm saying. Like each pancake would have a type plus or minus, and then I would just use those objects, but it's just a string, so I didn't need to worry about that. So it's read left to right, which is basically top to bottom. So for each test case, output one line containing case x and y, where x is the test case, y is the minimum, number flips. Again, it's from 1 to 100, or 1 to 10 for small tests, 1 to 100 for large. Okay, so this, I messed up also on this. I thought that this was actually case 1, whereas these are actually the cases, and then I thought, oh, they want us to say that if you input something at 5, when it's one flip, that means their logic was that anything that wasn't a plus in this logic would just be minuses, or just non-pluses would. So yeah, I just misread it, which made me completely get this portion incomplete, but that's not important. Anyway, so case 1, it would take one flip, of course, because it's 1 minus becomes 1 plus. Case 2 would be 1 flip as well. This 1 minus would become plus. This is already plus, so 0 plus. This would be 2 because you can't just flip this. It would be sorry, this would be flipped. Let's see. Yeah, minus minus, and then it'll be plus plus, so 2 flips, starting from the first one. This is already okay. This is 3 flips. So they did it differently from what my algorithm was. The first flip, yeah, so they flipped this to minus. Minus, minus. Oh, no, no. So this is the same way I did my algorithm, which was... Wait, no, they flipped the entire stack. Okay, so this is different. Wait. Yeah, this is different. They flipped the entire stack to get plus, minus, plus, plus. Then they flipped the top to get minus, minus, plus, plus. And then they flip these two again to get plus plus. So my algorithm was I wouldn't flip the whole stack. I would just, every time there's a difference, so minus plus, I would flip everything before that difference. And then I would keep doing that until they were basically all the same, and then I would do a final check to make them all pluses. Or that's basically the gist of it. So I did in Python. Python's probably my most natural language now. I was a C++ programmer for a while, but Python's a lot easier for stuff like this, I feel like, where it's dealing with strings. It's just a lot more manageable, I guess. I don't know how to explain it. I'm sure someone has an in-depth reason as to which, maybe it's not Python, but which language is best. I pretty much am confident that Python's the best language for stuff like this, but what do I know? Anyways, flip pancake, this basically, so this takes the pancake, the whole string. At what length will it stop? So it has to start from the start, or it has to start from beginning no matter what, but you choose when to stop. Flip is the new string. Start from 0. for X and Pancake, if the count is still less than the stop part, you flip them, the new string will have it, or else you keep the same whatever it was. Return string, very basic. Is happy. So this basically determines if this is basically my check of determining if I accomplished it or not. So is happy is non-happy. So I do a count of how many minuses there are first. If they're all minuses, then I basically just flip them all, and I will say that now they're happy, and I return what was this? I return how many flips I did, which was one whole flip for the whole row, and the new string, which wouldn't matter in this case, but it's needed for the other cases, maybe? Yeah. Anyways, non-happy, I check if there's no length. If there's no length, or sorry, if there's no happy ones, then I return true. Yeah, so I'm okay. And then if there is like something between non-happy, or all of them being non-happy and one being happy, then I'll return false and the same string. I don't know why I returned the string, but because it doesn't, yeah, whatever. Okay. Probably not needed, I'm pretty sure. So serve pancake. This is basically my main function. You take in the row, stack pancakes. How many flips is started with 0, of course. If the length is 0, you just this doesn't occur because there's always something, but whatever, you return 0. If it's 1, then you just check it. If it's a minus, you add a flip because that will become a plus, and then you return it. But if it's a plus, it's already 0. It's good. All happy, you start with false. While it's not happy, you keep doing the flipping. So this is where I'm looking for changes. So I'm going over the whole pancake stack. If the current, so I start with 1 because I always check with the previous iteration. And this works for ones that are 2 or greater, and the ones I handle here. Anyway, so if there is a change, okay, then the stack of pancakes, I do a flip. Not sure what happened. I heard a noise, but anyways, so I do a flip of where that change occurred right up to it. So that's the -1 part. That's so this was, where's my examples? So here it would occur at element 1, 0, 1. That would be flipped up to there. So I flipped the pancakes up to the change, and that change happened at 1 and 2. So 2 does not equal 1, then you flip up to 1. You add a flip count to the counter. Then you do a check. So I always do a flip, try to flip first, then I do a check. And if it is happy, then you break. If not, whatever, you do this as happy check. Again, checking if they're all happy or all not, or else you keep doing your flip throughout the whole string. Return string, there. So now, this is Python 3, I believe, so I need to do this. Don't really need that. But okay, there. And with the file they gave me for the, I think it's the large one. Pretty sure it's the large one because the small one is only 10. Let me see. Download. No, it's not. Oh, it's not download. Not downloaded? Okay. Is it the small one that... Oops. Wait, why is it... Hmm. Okay, why is the small one 100? And the large... No, this is small. It was the large one. I thought the small one would be 10 and the large one would be 100. But maybe I'm wrong. No, large is also 100. What's the difference again? Maybe it's the length of them? I don't know. So I have the small one, ran it. This is correct. I'm just doing like a basic check of correctness. I'm not sure. I'm pretty sure this is the most optimized way because even though it's like a very different from the way they presented their solutions, because this was completely different from my algorithm. I would do again plus plus plus, all minuses, all pluses, whereas they flip them all. Flip this for some reason. I'm not sure how to even like write that algorithm. It would basically be my algorithm, except they start with flipping all of them because it starts with minus, which is why not just, I guess, I don't know, I'd probably have to see more examples, but I'm guessing that instead of ending with all minuses and then make them all pluses, this doesn't need to do that. It'll end with all pluses before ending with all minuses, is my guess, but I don't know. Not important really, I don't think. So this is changed to minuses, changes to pluses, then change it to all minuses, and then all pluses again. Yeah, so that's all. I will have probably upload this on my GitHub account. You'll see in the below. If you want to try to use this solution, it could probably be cleaned up a little better, but yeah, I think this. Let me know if I'm like wrong in any way, and thanks for watching.